So here's an example of an acceleration problem for you guys. So straight line motion. Um, so in this case, we have a car starts from rest, travels a distance of 45.8 meters in 2.65 seconds. So we're going to have a distance of 45.8 meters. We're going to cover that in 2.65 seconds. Since we're starting from rest, VI is going to be 0 meters per second. So what does that mean? That means that we can go off the fact that our distance equation is going to look like d equals VIT plus AT squared over 2. That would give us the full range of all the variables we're looking at. Because VI is 0, we can get rid of that. And then we can solve for A. So A, we move some variables around. It's equal to 2D over T squared. So then we can put our values in for D and T. So 2 times 45.8 meters over 2.65 seconds squared. And then with our calculator, we get 13.0 meters per second squared for our rate of acceleration. So the next question asks, what's the top speed? Well, there we're looking for VF as our unknown. We're always know that VF equals VI plus the acceleration times the time. It's going to tell us how, based on how long we're accelerating for, that'll give us our final speed, especially because VI is 0, so that's going to go away. So you just take 13.0 meters per second squared, multiply that by the time of 2.65 seconds, and multiply that by 2.65, and we get a final speed of 34.5 meters per second for the car. So this car's obviously accelerating really quickly, going from 0 to 34.5 meters per second in just 2.65 seconds, which is why our acceleration rate is so high. So we're going to maintain that top speed for 6.25 seconds. Well, that means we're going to stay at that speed. So we're going to be constant motion, where distance equals v times t. The velocity is 34.5 meters per second. We're going to go with that for an additional 6.25 seconds. So if we do that, we find out that we're going to go an additional 215 meters after those first seconds. So that means in total, we're going to add in the other distance we covered, 45.8 meters, and we're going to end up with 261 meters as the total distance we traveled. Okay. Again, understanding here that this was the car speeding up for the initial segment here, so here's where the acceleration is happening. And now here, for the longer section, this is where we're going at a constant speed. So we have two motions that are taking place. In the end, we now have a third motion that's happening here where the car is slowing. So now we're going to go to stopped. The time it's going to take to stop is 1.34 seconds, really quickly. VF is going to be 0 because we're coming to a stop. The VI is going to be the top speed from the previous part, or 34.5 meters per second. So based on all that, if we want A, well, if we have VF, VI, and T, A is pretty simple. It's our basic definition of acceleration, change in velocity over time. So 0 minus 34.5 meters per second all divided by the 1.34 seconds, and 34.5 divided by 1. And we get a rate of acceleration of negative 25.7 meters per second squared. Obviously, this is extremely high, given that it's about 2.5 times the rate of acceleration due to gravity, but based on the information problem, this is what you should be looking for.